Hello, everybody. My name is Sophia.
And I'm Lillian.
And we're members of the FTC Team 11225 Delta Robotics.
Today, we'll be covering an interesting topic, state machines.
Buckle up and let's have some fun. Okay, so first of all, what are state machines? State machines, specifically called finite state machines, are behavioral models that will perform transitions or outputs based on the current state and input. In other words, state machines consist of two things, states and transitions. Surprising, we know.
Some real-world examples include vending machines, traffic lights, and combination locks. These all have several different states that the code shifts to and from depending on our inputs.
Here is a quick diagram of how our first project will work.
In this example, when the right bumper of the controller is pressed, then the robot's state transitions. When the right bumper is pressed, the claw will close. And when the left bumper is pressed, the claw will open. This type of logic will be used for all state machines.
Now, in order to identify the two states that will be used in this specific state machine, ask yourself this question. What are the states that are being stated? I'll give you a second. If you said claw open and claw closed, you're right.
The only way the robot can move from an open claw state to a closed claw state is through transitions. So then, what are the transitions in this case? It's the actions or our inputs. So the answer is when the right or left bumper is being pressed. Now that you've got the hang of it, let's take a look at our Java code.
Now you see some of the meat of the state machine code, and this is our project 1. At the beginning of our code, we start by stating or naming our two states, claw open and claw close. And remember, this all has to be capital letters. Later, under the public loop, we will define the robot's condition under these two states. For now, let's take a look at our next line.
This statement is essential because it defines what state the robot starts in. In this case, the robot will begin with an open claw. Following that, we created two double variables for our claw servo positions, naming them claw open and claw close.
Next, these lines below are for setting up the servo that we will be using. Remember, servos use .setPosition, not setPower. Now we will create the loop, which will become your best friend. So pay attention. 3 important words in the loop for state machines are switch, case, and break. You will be quizzed later, so remember this.
The switch allows the robot to move between the two states we defined earlier, depending on our inputs. The case is for introducing our state. Anything between case and break are the conditions the robot will follow when it is in the claw open state. The break prevents the robot from continuing to follow these conditions when it switches over to the claw closed state.
After you finish creating your first state, repeat the process for the second state, but by using the right bumper instead. Congrats! You have now finished your first ever state machine code. Yippee! Now, we're not technically all over yet. So, what if you come across a bug and you have no clue what to do?
First, write your code out in pseudocode. This was extremely helpful for us because it helped us clean up our logic and find our bugs. One of the great things about state machines is that it helps organize the code and make it easier to find issues we come across.
Secondly, add a telemetry line for the two states, so you can directly see on the driver's hub which state the robot is currently in, making it a whole lot easier to identify the bug. If you are still stuck, follow these steps. First, walk through the logic of your code. Make sure it makes sense. 2, make pseudocode. Remember, this code isn't actual code, just in words of what you want your code to do. Third, now write the code so that it matches the pseudocode. Fourth, test it. Make sure it works. If there's any bugs, try again. And if your code did not behave as you wanted it to, repeat these steps one more time.
State machines may seem tedious right now, but it will make life much easier for coding in Java. Remember, we are coding in Java. It's okay to make mistakes. While testing code, we ran into many errors because of small mistakes. Keep working. Go first! Go FTC!
Yay!
Yeah!